Welcome to video 3. Yesterday we learned about constructing a confidence interval for slope, and today we're going to learn how to actually do the significance test for slope. This is our formula for our test statistic. It's a t because we're using the t distribution, and it's equal to the estimated slope minus the hypothesized slope divided by the standard error of the slope. So it fits the model for every test statistic that we've done so far. There will, as usual, be 3 different types of tests, a right-tailed, a left-tailed, and then a two-tailed test. And the alternative hypotheses for these all mean something different. For a right-tailed test, we're thinking that the slope is probably positive. For a left-tailed test, we're thinking the slope is probably negative. And for a two-tailed test, we're hypothesizing that it's not 0, it's something other, but we don't really know the direction. So those are the 3 different types of tests. And we'll be finding our p-value, and we'll be doing that using our t-distribution and degrees of freedom is n minus 2. So let's look at a problem. So infants who cry easily may be more easily stimulated than others. This may be a sign of higher IQ. So they did a study, they actually did an experiment, and child development researchers explored the relationship between the crying of infants 4 to 10 days old and their later IQ scores. So they basically took the infants, measured their intensity. So along the x-axis here, our explanatory variable is count of crying peaks, and then the response variable is IQ at an age of 3 years. So it's positive. It's not very strong though, but it is a positive linear relationship. So from looking at that, I think we'll probably be able to assume the linear condition is met, but we need to look at the residual plot as well. So we have here our y-intercept, of course. We have our slope, and we have our s. So this is saying on average, the residual is about 17.5, and it would be IQ points because that's our response variable. So the question here is, do these data provide convincing evidence that there is a positive linear relationship between crying counts and IQ in the population of infants? Or is this something that just happened by chance, what we're seeing or what we're observing here? So our null claim, our null hypothesis is going to be that the slope is 0. And it's really helpful in this unit to write out your hypothesis in words as well. And that just means there is no linear association between crying and IQ in our population. The alternative here, because they are suspicious that is a positive relationship, we'll be doing a right-tailed test here. And the alternative is that there is a positive linear association between the 2 variables. And we're going to use an alpha of 0.05. So we need to make sure our conditions are met. So as I mentioned, we have a scatter plot. It's somewhat strong, not terribly strong, positive, and it is linear. And if I look at the residual plot, I see there may be a large residual right here, but overall there's pretty even scatter above and below the y is equal to 0 or residual equals 0 line. So for that reason, I think we can proceed and say it's reasonable that this is a linear relationship. Independent, because we were sampling, or we did sample, we need to make sure that we meet the 10% condition or 10% rule, which is that the population is at least 10 times the size of the sample, which we're saying here the population has to have at least 380 infants for this to work. And that seems reasonable as well. And it also seems reasonable to think that later IQ scores of individual infants should be independent of each other. So we can proceed with the independent condition also being met. Normal. The normal probability plot here, we'll look at it here, of our residuals is pretty good through the center, but if you look at the tails, it kind of skews off, basically showing some skewness here or a departure from normality. But because our sample is 38 in size, and we know that T procedures are robust against departures from normality, we can proceed with this inference. Equal variance. So we're going to go back to the residual plot, and we're going to look for an equal amount of scatter above and below the horizontal line. And it looks pretty good. You have this one big residual there, but overall it's reasonable to assume that there's equal variance. And then finally we are told that these 38 infants were randomly selected. So all of our conditions are met, at least reasonably so that we can do our inference. Okay, so here is our regression output. Just a reminder of what our formula looks like. So we're going to take 1.4929 minus our hypothesized slope, which was just 0, which is usually what it is. Not always. And then we divide by standard error of the slope. So it's given to us right here. So we're going to just plug that in and get our test statistic, which is 3.0655. Now, I want you to notice that if you look at the output, and I told you I'd come back to these two values here, do you notice that it is the same value of t here from the computer output? So it's actually giving you the test statistic on the computer output. But you need to make sure you know how to use the formula to find it yourself as well. Then the next thing is we need the probability. So we need this area in the right tail here. And so we're going to use TCDF 3.0655 to infinity, and our degrees of freedom is 36, and we get 0.002. Now, if you look at the p-value here, it is not equal to 0.002. However, it is twice that we just found. And what is going on here is that the computer output gives you the p-value for a two-tail test. So if you know that, you can just simply divide this by 2 to get the area and the right tail. Or you could do it by hand, and you need to be able to do it both ways. So our p-value, which is 0.002, is less than our alpha 0.05. So we have enough evidence to reject the null and conclude that there is a positive linear relationship between intensity of crying and IQ score in the population of infants. Now, can you do this on your calculator? Absolutely. But as every test that we've done in the calculator, you have to be able to do it by hand as well. So if you want to do the test for slope, you're going to do Lin-Rag t-test. You're going to need to have the data, your x or your explanatory variable probably in list 1, and your response variable probably in list 2. What about the confidence interval? Absolutely, you can do the same thing. It is Lin-Rag t interval. Same exact thing. You have to have your list 1 and list 2 entered, and then you just run the test or construct the interval. And the other thing that I would point out is that you get the S, which is the standard deviation of your residuals, or the standard error of your residuals, from both of these tests that you can run. So you'll need that for the formula, so make sure you know where that is. And we talked about that earlier as well. So I want you to complete 12.1 quiz. It's a worksheet. I want you to treat it like a quiz. Do your best on it, and we will check that tomorrow. And you can ask questions on anything you don't understand so far. Have a great night.